In this video, we'll look at how to work out the slope or gradient of the tangent at a point on the curve. So we have our 2 points, point A and point B, and I want to work out the slope of the tangent at point A. What we have first up is a chord between points A and B, and we've seen before that if we calculate the slope of that line segment, we have the average rate of change. The instantaneous rate of change will be the value of the slope of that chord as B gets closer to point A. Here we can see that if we were to move point B around closer to point A, then that blue dotted line, which is the slope of the chord, will approach the green line, which is the tangent at point A. And when point B is on point A, then the two lines become the same. So the closer that point B moves to point A, we end up with the slope at the point A, the slope of the tangent. So now if we were to work out the slope of that line segment between A and B, then we know that we need to first of all work out the difference in the x values. So the x value at point B is A plus h, the x value at point A is A, and therefore we subtract the two for our denominator. Then we work out y2 take y1, and point B, the y coordinate is f of A plus h, and for point A, the y coordinate is f of A, so we subtract those two there. Which means we end up with a calculation for the gradient, the A plus h and the minus A, simplified to just h on the denominator. And this represents the change in the y values compared to the change in the x values. And these notations here you will see depending on your text. The one that I will mostly use is dy by dx, but you'll sometimes see delta y divided by delta x, and this expression here, which also means the same thing. But you'll rarely see me write that. So the change in y compared to the change in x, that's our slope. Rise on run, or y2 take y1 on x2 take x1. Now the instantaneous rate of change, as we said, is the slope of the tangent at point A, which means we need to move B closer to point A, and then we'd find the instantaneous rate of change at this point here. Which therefore means we need to consider what happens when that gap of h gets closer and closer to 0. So as h gets very small, or as h approaches 0, that's when we'll work out what the slope at point A is. And that will require an understanding of the idea or the principle of limits, the limiting value of our function.